Hi, we'll be beginning Chapter 2 today, and the very first section is on linear equations in two variables. These are some important facts that you'll want to write either on a note card or some sort of piece of paper so that whenever you go to take a test you can have all of these formulas and equations handy. Now, this very first one, the slope. Slope is something that we use to describe how a line or some sort of function is rising as x changes. So we will describe it conceptually as being rise over run. You know the formula, I'm sure. M equals y2 minus y1 over x2 minus x1. That's our formula that we're going to use if we know 2 points. You will hear it described as rise over run. You will also hear it described as delta y over delta x, which means change in y over change in x. Also, especially in word problems, you will hear them ask for the rate of change. When you hear rate of change, think slope, because that's what they're asking for. Now, there are 3 different ways that we're going to describe our lines and 3 different forms that you'll need to have handy. Number 1 is the slope-intercept form. That's one of my very favorite forms, y equals mx plus b. My favorite form is this because you can read off the slope, that would be m, and you can read off the y-intercept, that is b. The point-slope equation of a line, this form you can find a general equation if you know a point and you know the slope. That's why it's called point-slope. The general form of a line, you'll see it written in this manner sometimes. It just puts everything all on one side and has a coefficient in front of x and one in front of y. Now, as a review, you'll want to remember that parallel lines have the same slope and perpendicular lines have negative reciprocal slopes. All right, we're going to go straight into graphing some lines and looking at their slopes. Here's an equation of a line that I've graphed for you. The equation is y equals 2/3 x minus 1. Now, this is in slope-intercept form, so you should be able to read off the slope. The slope in this case is 2/3, and the y-intercept is -1. So let's look at this graphed on our grid here. Y-intercept we can see as being -1. Let's look to see how the slope is 2/3. They're going to give you some lines in your homework or on your test, and you're going to have to just look at the graph and tell me what the slope is without knowing anything else about it. What you'll do is just pick 2 random points. So I'll pick the y-intercept since he was right on a crosshair there. And I'm going to look at how it rises over how it runs to get from one point to the next. So in starting at this point down here on the left, and I'll always go from left to right, it'll make my little calculations easier. I will rise 2 and run 1, 2, 3 to get to the next. And if you will notice, I can rise 2 and run 1, 2, 3, and I will still be on this line. No matter what I do, if I pick any point on this line, if I rise 2 and run 3, I will be on that line. The next line I graph for you is -3x plus 2. So let's look at the slope. The slope would be -3. The y-intercept would be 2. So let's check that out. Where y is 2, yep, it's crossing the y-axis there. Let's go from one point to another by going down 3 because it's -3 and running 1. The slope is actually -3 over 1 because I can write any number over 1. So if I go down 3, 1, 2, 3, and run 1, I will see that I'm still on that line. And of course I can go down 3 and run 1 anywhere on this particular equation, and I will see this equation that I've graphed, and I'll see that I'll still be on that line somewhere. Going back to my things that I need to know, I've looked at the fact that slope is rise over run, and we've looked at the slope-intercept equation of a line. You'll be given 2 points, and you're going to be asked to find the slope of these 2 points, knowing that the formula is m equals y2 minus y1 over x2 minus x1. What you will do algebraically is you'll choose one of these points to be point 1 and one of them to be point 2. Then you will plug in the y value from point 2, that would be a negative 4, minus the y value from point 1, that would be a 3. Then I'll plug in, I need the x value from point 2, that would be a 2, minus I need the x value from point 1, that would be a negative 2. Calculating this value, I would have negative 7 over 4. The slope between these 2 points is negative 7 over 4. In other words, if I draw these 2 points on my grid, negative 2, 3, and 2, negative 4, and draw a line between the two, in order to get from one point to the next, I would need to go down 1, 2, 3, 4, 5, 6, 7, and run 1, 2, 3, 4. Negative 7 over 4. And that's what we found our slope to be. All right, now let's extend this example because we know we have a line between these 2 points, so let's find the equation of the line. Find equation of line between these 2 points. We would need to use our point slope formula because we now have point, in fact we have 2 of them, and we have a slope. So y minus y1 equals m times x minus x1. And just plug in our values. So let's do that. We need a little more room. Okay. I get to choose whichever point I like, whichever one I think is the coolest. How about using this point here? It really doesn't make any difference. You can choose to do this by yourself and choose the other point, and you'll find that it'll simplify to the same thing. You just choose the point that you think is the coolest. So y minus, I need the y value from my point. That's what this y1 represents. So y minus a negative 4 equals m, negative 7 over 4, times x minus, now I need the x value from the point I chose, that's a 2, and then I just simplify this little sucker. So y plus 4 equals negative 7 over 4 x plus, and then I would have to multiply negative 7 over 4 times this negative 2, that's why I wrote a plus. So that would be 14 over 4, which is then 7 over 2. I'm going to subtract 4 from both sides, knowing that I need a common denominator. Y equals negative 7 over 4 plus, I'll subtract 4 from both sides. Oops, I forgot my x. Don't drop your stuff there. Okay, so I'm going to say 7 halves minus, and I'm just going to go ahead and write 8 halves because that is what 4 is. It is 8 halves. So my equation for the line would then be y equals negative 7 fourths x minus, looks like 1/2. All right, let's go check out our graph and see what he looks like. All right, here's the equation we came up with, negative 7/4 x. We looked at the fact that the slope was down 7, run 4, and it says that our y-intercept should be at minus 1/2. Look at there. Isn't that sweet? It's sitting right there. Okay, we've looked at this little thing as long as we can, I think. Let's move on. All right, now let's assume that we want to put this in general form. I would need to get rid of the fraction, and how I'm going to do that is I'm going to multiply both sides by, I believe a 4 will do it for me. So multiply both sides by 4. And then I'll move everything all over to one side. So this thing would look a little prettier as 4y equals, and then I'm going to distribute this 4 to both of these. Negative 7/4 times 4 is negative 7x minus, multiplying 4 times 1/2, that's going to be a 2. Shooting everything all over to the other side, 7x plus 4y. Moving the minus 2 over, plus 2 equals 0. And there she is in general form. Here's a couple of parallel lines that I've graphed for you, and I wrote their equations out to the side. The blue one is 2x plus 1. The red one is 2x minus 1. They have exactly the same slopes. I can read that off of here and here. M equals 2 in both cases. And you can see that their rise and their run are exactly the same. Their rise over run is exactly the same. These are two perpendicular lines. You can see from their equations that the slope on the blue line is 4, and the slope on the red line is negative 1/4. We say that they are negative reciprocals of each other because if you flip the 4 over 1, you get 1/4, and one's positive and one's negative. In order for them to be perpendicular to each other, notice that the slope of the blue line goes up 4 and runs 1. If you compare that with the red line, he's not near as steep. Let me choose a couple of points here. Let's choose this point here. Say to, I'd like to look from there to, let's say right here. Look at his rise over run, and you will see that he goes down 1 and runs 4. Notice how the little triangles here that we've drawn are exactly inverted, or they're exactly flip-flop. The rise and the run flip-flop from each other. And those are perpendicular lines. So if you're to find out whether two lines are perpendicular, find the slope of each line. So let's say if the slope of line 1 is negative 1/2. And you need to know that what the slope is of line 2. You say, well, I would flip the 1/2 because the rise and run flip-flop. And if it's a positive line, the perpendicular one would be negative. And if it's negative, it would be positive. So this would be positive 2 over 1, which would be 2. So these two lines are perpendicular. All right, here's our very last problem that will encompass everything that we've learned so far, and will complete the section 2.1. All right, suppose you're given a line that goes through the point negative 2, 3, and it's perpendicular to the line negative 2 plus 1. What's the equation of the line going through the point negative 2, 3? Well, let's get a picture of what this looks like. All right, here's our picture. We have a line that goes right down through here. His equation is negative 2x plus 1. There he is. We also have another line that goes through this point right here and is perpendicular to that guy. So he's going to kind of look like, I guess maybe, we'll just kind of draw a little guess of what we think he's going to look like. He's got to go through this point and kind of be perpendicular. So given just kind of a quick guess as to what he looks like, kind of is going to look about like that. So we're going to have a line that goes about like that because he goes through that point to negative 2, 3, and he's perpendicular to our blue line. So let's go find the equation. Well, first off, we need to figure out what's the slope of the line that they gave us. The slope of the line they gave us is reading off of this right here would be negative 2. All right, but that's not the slope of the line that we're supposed to find. Our line is supposed to be perpendicular to this guy. So our line, the one that we're looking for, our slope is going to be the negative reciprocal of that, which would be 1/2. Then we have, so this would be, we call this M1 or something, our blue line that we saw in our picture. And then he goes through the point negative 2, 3. Well, now all we have to do is just use our point slope equation of a line. And there he is right there. You'll find him very useful when doing your homework and taking the test. So we'll say y minus, we need the y value from our point, which is 3, equals m, which is 1/2, times x minus the x value from our point. The x value from our point is -2, so minus a -2 would be +2. I'm just going to go ahead and write it down. I'm going to distribute the 1/2, so I would get 1/2 x plus 1/2 times 2 is 1. I'll add 3 to both sides to kind of clean it up a little bit, and y equals 1/2 x plus 4. And that's about as hard as they get in this section. If you have any trouble with these, see the discussion board and or send me a message, and be sure and attend the eLives to ask me any questions.